Now, because water is such a common and important substance, we're going to spend this lesson looking specifically at the density of water. So we remember that the density of water is 1 gram per cubic centimetre. So as we learned in the previous lesson, we can also write this density as kilograms per cubic metre, or metre cubed. And we remember to make this conversion, we have to multiply the figure here by 1,000, so that's equal to 1,000 kilograms per metre cubed. Now it's important to visualise this, so think about what a cubic metre looks like. So for example, you've got a plastic cubic container here, 1 metre by 1 metre by 1 metre. If you fill that with water, it will weigh 1,000 kilograms, which is equal to 1 metric tonne. Now, since water is a liquid, we often refer to its density in terms of kilograms per litre. Think about what a litre is there. You've got a litre carton of milk. Well, if you empty that and fill it with water, then a kilogram of water will fit into that carton. So we can say that the density of water is also 1 kilogram per litre. Okay, so if you think about this for a minute, that's 1,000 grams in a litre. And since there are 1,000 millilitres in 1 litre, then we can write the density of water as 1 gram per millilitre. So for example, in this measuring cylinder, if I have 30 millilitres of water in this measuring cylinder, then I know that that water will weigh exactly 30 grams. So it's important when we're dealing with water to be able to transfer between volume and weight. I know that that 30 millilitres of water weighs 30 grams. If I half fill this container here with water, then the mass of the water will be 500 kilograms. So the next important thing we're going to say about water is this, that when water freezes, that's to say when it solidifies into a solid, something unusual happens because its volume actually increases. Okay, we say that water freezes, and again, because water is such a common substance, we have a special name for water in the solid state, which is ice. So while the density of water in the liquid state is 1 gram per cubic centimetre, because its volume increases when it freezes, its density actually reduces. So the density in the solid state is about 0.93 grams per cubic centimetre. Now, a result of this strange reduction in density as the substance moves from the liquid to the solid state is that ice floats on water. And in fact, because this is seawater, it's not actually pure water, the density of the seawater is typically about 1.03 grams per cubic centimetre. Alright, and since the density of ice is 0.93 grams per cubic centimetre, there is approximately a 10% difference in densities. And as a result of that, 10% of the iceberg will float above the surface of the water. Approximately 10% of its volume is above the surface of the water. So the next thing we're going to say is this, that if we've got water here in the liquid state, and supposing that its temperature at the moment is, say, 10 degrees Celsius, for example, and if I heat that water, if I let that water warm up to, say, 60 degrees Celsius, well, the water will expand. Okay, it will expand very slightly, but it will expand, and as a result of that, the density of the warmer water will be less than the density of the cold water. So hot water will actually float on top of cold water, and you can demonstrate this. There's a demonstration of this in the practical demos section. In fact, if you mix cold water with blue food colouring and hot water, for example, with yellow food colouring, and if you're very, very careful, you can actually pour the hot water on top of the cold water so that one floats on top of the other. You might like to watch that video. Now finally, I'd just like to talk about the density of solutions. If I have pure water here, again, well, we know that the density is 1 gram per cubic centimetre. And if I add salt to that solution, or sugar, or some particle that dissolves in the water, well, what's going to happen is I'm going to increase the density of the water. So for example, if this were salt, and these symbolically represent the salt particles, well, we know that the particle of water, which is the water molecule, well, the molecular mass of the water molecule is 18 grams, whereas the molecular mass of a particle of salt, or sodium chloride, is 58.5 grams. So you're adding heavier particles to the water, and as a result of that, the average mass of the solution per given volume increases, so its density is going to be greater. Likewise, as with the hot and cold water, there's a practical demonstration of this where you can see clearly that you can float pure water mixed with food colouring on top of salt water mixed with food colouring, because the pure water has got a lower density. Now there is just one more important thing I'd like to add about the density of water. Now you might have said at the start, well, what an incredible coincidence that such an important and common substance as water has a density of 1 gram per cubic centimetre. Well, that is not a coincidence. That is because the density of water was arbitrarily chosen or defined to be this. Let's just make a note of that. So its density was arbitrarily chosen sometime way back around about the start of the 18th century, when the metric units were first introduced in Europe. So somewhere around about then. I'm not a historian, but the point is that it's not a coincidence. These were arbitrarily defined, and so all other densities are measured relative to that of water. Now this business about choosing water is not an uncommon thing. For example, you remember that Celsius did exactly the same thing when he defined his Celsius scale. He used the melting point of ice to define the 0 point on his scale, and he used the boiling point of water to define the 100 degrees Celsius point on his scale. And with those 2 points he was able to define the temperature scale that we use today.